All right, in this problem, it says that the bat that the softball player is swinging starts from rest. Well, we're doing rotation, so from rest means omega naught equals 0. And then it says it gets to a speed of mine says 3.5 revolutions per second. Yours probably says something different. That's going to be omega, but that's in the wrong units. We're doing a torque problem, and we have to have our quantities in the right units. The right units are radians per second. So I'm going to take my 3.5 revolutions per second and change it to radians per second by multiplying by something with revolutions in the bottom and radians in the top. Because that way my revolutions are going to cancel with each other and I'm just going to have radians. So I need to put something in here that's true, and one thing that's true is that 1 revolution is 2 pi radians. So I multiply that out and I'm going to get the omega in the correct units. Now, it says that this takes a time of whatever it says for you. So we have the time. It says approximate the bat as a 2.6 kilogram, or whatever yours says. It gives you the mass of the bat, uniform rod of length 0.95 meters. And I think everybody has the same length because that is the length of a bat. All right, and it says to calculate the torque that the player does. So we need to find the torque. So there's what we have, that's what we need. And so we look into our bag of tricks, and the only equation we have with torque in it is torque equals I alpha. And that means that we have to have I and we have to have alpha to calculate the torque. They didn't give us either one, but that's okay because we can calculate them. So let's calculate I first. To find I, we look at the list of equations for something that applies to the shape that we're using. And so it says that it's a uniform rod. And on the list of uniform rods, there are 2 possibilities. One of them is the rod being rotated around its center, and the other one is a rod being rotated around its end. So you have to think about how a softball bat is used. And really, you hold it at the end and you rotate it around the end. It's not like twirling a baton when you twirl it around its center, right? So we're going to use the one that goes around the end, which is 1/3 mass times the length squared. And since we have the mass and the length, we should be able to calculate the moment of inertia. Yay! Now we have to find the angular acceleration. And where that's going to have to come from is kinematics, because what we have is angular velocity and time. We need to get to angular acceleration. We need kinematics. I'm always hoping to be able to use the easiest equation, omega equals omega naught plus alpha t. So I always check that one first. We have omega naught, that's 0. We need alpha, and we have the time. So yay, we can use this equation. So we solve this for alpha. That's going to be just omega over t. We've already changed omega into the right units. T's in the right units. So we can calculate alpha, and then we're going to put the alpha and the I together into this equation to do the final calculation.